Hello everyone, welcome to episode 2 of the tutorial. I think I fixed my mic so it sounds better. Okay, what did it do here? So in today's tutorial we're going to be working on rendering out these sprites to the screen. Okay, so rendering this is going to be a little bit weird because this is a normal grid. Have we ever X across this line and our Y across this line? It's rendered exactly point to point on the grid. It's like if I want to go here to 1, 2, I just need to render it here. But on an isometric, it's different because we have it offset weirdly. So it's supposed, I think I rendered this wrong, it's supposed to be, so it's like, the X is like twice the length of the Y, making like these cool diamond shapes. So if we want to go over 1, 2, we need to like find out how to like take our 1, 2 point. Then we're going to convert that to screen chords, which should look something like, so 1, 2, it's not as simple as here, so we're here. If you want to find out what that is in screen chords, we're going to use an algorithm known as, or not algorithm, but we need to like x minus y. So we have that for our x, and it'd be y plus x divided by 2. This is the equation if I remember it correctly. So now let's get into programming this. But before we can render this, we're going to need some extra functions and classes to render them. So the first thing is we need a tile size. We're using 64 pixel tall sprites, but like we only like want this area, and something's wrong with the equation, I think, so we need to use half of that, so 32. Or I think that's how it works. So now we're going to have a def to screen chord. To screen chord. So what we want to take in is our x and our y. Then we want to return x minus y, comma, okay, so this one needs to be x plus y divided by 2. That's the equation I wrote down earlier. Let's also make a def render where you just need an object that we're going to draw to the screen and a screen. So this screen thing is where we're going to render all the objects. So what we're going to need to do is we're going to need screen dot split and then we need our object dot image by our object. Wait, we need to go to screen chord. So what this does is it's going to convert it to the screen cord, and it's going to draw it to our screen. Now let's create some more classes for our player and stuff. First, we can go here with the class tile. So the tile class, it's going to hold all our information for our title. And so here in our init, we want self dot no self. We also want to have an x and a y. So how we're going to do this is we're going to self dot rect dot x. Self dot rect is actually, I'm doing this wrong. Self dot image is equal to pygame dot image dot load. Now our tile is called tile.png, so let's type that in. Tile.png. Now we want our self.rect is equal to pygame dot image dot load. Wait, what am I doing? This should be self dot image dot get underscore rect. This is gonna get the rect of our image at the exact size so we can use it for collisions. So how this works is it's gonna look through this. It's scrolling weirdly. So what's gonna do is it's gonna take this, gonna find out how big our image is. It's gonna create a rectangle that's 64 by 64 pixels, about the same shape as this. So we're gonna use that for collisions and everything. Now we want our self dot rect dot x is equal to x times our tile size. Self dot rect dot y is equal to y times our tile size. That's enough for the tile. Now we're going to create something called a level.text. This is what's going to store our level. Since we're using levels to store the text file, that will make it so that we can easily store and load levels for later use in our game. Right now, let's just build a 4x4 square. This doesn't look like a square, but it is a square because how things are rendered in the text editor thing. The height is taller than the width. So now we want to def load level, or take our level. First thing we want to do is f is equal to open our level. Open level dot tag or dot text. We're gonna read it. Now we want our data to be stored as f.read is equal to our f.read lines. So this will give us the information in a list like this. This will be line 1. This would be line 2. This would be line 3. And this would be line 4. If we used f.read, it would have each one of these zeros as its own separate list. So I need to use f.read lines. Now let's just print the data to make sure that we're doing it right. So here in our start, we want to load so why is it doing that? Okay, yeah, it's doing something. I don't know what it's doing. Oh, we forgot to define it's going on def load level. Oh, why do we have a level.text? That should be our string. Level.text. Okay, now it's not working. Oh, it needs to be self.load level. I keep forgetting this. So now after we run this, okay, yeah, something broke. Def load level. Yeah, why is it not working? Oh, we forgot to capitalize all this. Okay, I just wasted like an extra 5 minutes of your time. Okay, that also needs to be a string. Or do I even need to put them reading it? So now if we look, we should be able to see that we have our data right here. Almost exactly how I stored it, except I forgot to put these as string. Put them as extra list. So now here in we need self. We're gonna turn each one of these into tiles. So we need a self dot t is equal to tiles is equal to a list. So now what we're gonna do to this list is so what we're gonna do is we're gonna every time that when we're running through this, so what we're gonna do is we're gonna go through each one of these. So it's gonna read the first one, it's gonna be a 0, it's gonna put a 0 there. You're gonna read the second one, there's gonna be a 0, it puts a 0 there. Third one, 0. Or it doesn't put a 0, it puts a tile there. So it turns this into a string of tiles. Let's see, load level. Probably get rid of this, we don't need it. And this. I'm gonna go for y in range. The length of our data. copy this line, sit down here for x and range for length of the y value for data. This is going to return a string from our list. This is going to return the index of the character of the string from the list. Here if data y x is equal to a string of 0, because that's whatever is their title. Let's see, now we want to do this. I go tiles dot append. This adds it to our list. So now that we need to append this, we're going to append a tile. So I just need an x and a y. So pass in our x value and a y value. Actually, I can do this better. I'm going to create a list called t and store it as a list. Append everything to t. Then we're going to want to return t. So every time we render a new map, it's just going to turn all the data here. Tiles should be equal to load. So it's going to do this. Void start self.tile is equal to that. So now that we have our list of tiles being generated, I'm gonna run this, make sure there's no errors. I accidentally messed up. Runs everything just fine. Now we need to draw each tile to the screen every frame. So let's go here to our main update. Self.render screen. Oh, we need to go to that. It's like right in between this. So here's what we want to do. We want to do for tile and self.tiles. We're gonna render our self.screen. Object needs to be a tile. Screen. Self.screen. Now if we run this, something bad's gonna happen. Self list is not callable. Oh, what did I do? What am I thinking? Now we have that. We're gonna need to offset it a little bit. That looks like that's about half. 32. 32 plus 64 is 32. 64 is 96. So we want to offset our y by 96. No, our x by 96. Plus 96. Now, if that's correct, we should have that right there, exactly like that. And look at this, since we're using a text file, we can make our own levels by just placing stuff around and deleting stuff. Now after run it again, we have a different level. So we can easily create levels like that. These look weird because I have it like that. So before I get started on the player class, I just realized we made a mistake. So this tile right here is 0, 0. Or I think it, yeah, it's 0, 0. Is it? So that should look like this. This is 0, 0. That should be in the center of the screen. So it's not 96, so we want to subtract. So we want to go back up to our thing, or we don't want to add 96. We want to put that in the center of our screen, so minus 400, half of our width. Then here, let's subtract 300. Oh wait, plus. We don't need the plus 300. Yeah, it's centered enough. 400 minus tile size. It's pretty highly centered. Just gonna keep it. So now we're gonna get started on the player class. Okay, so to get started on the player class, we're gonna have to create this like blower tile. Class player. But we don't need this on our class. I forgot about that. And when you're def underscore underscore init underscore underscore that self comma x comma y. Whatever the center. That wasn't supposed to be there. It should only be self.tiles. Let me like, yeah, that's right. So now to render this, we basically just want to copy all this. So I'm going to change this to player.png. Now here we went else if data y x is equal to, we're going to go with a p, so every time there's a p, it's going to spawn the player there. We only have one player. So we went self dot player is equal to a player this means a capital player C. You want this to be at X and Y. So now after this, under a player, we're going to need another event for moving it with the arrow keys lost. We're going to have to eventually add collision to this. So def Okay, so we want to call this update for a player. So now we want to keep in our self. Let's see, so we want K, this can be our keys to get our input. K is equal to pygame dot keys dot get underscore pressed. Make sure I haven't made a mistake. Still works. Let's just print K so we can see what we're pressing each frame. Now I want to go here to our update. While true. Self dot p dot player dot update. So now each frame, it should tell us what key we're pressing. Wait, what's I call my player? Oh, we don't have a player assigned. Oh, wait, that makes it so we can't assign players on that. Okay, so we don't want this. Just copy this, backspace this, because we can't add a player. Or actually we can, we just need to like add an extra tile below it. So now if we like change the top left to a player, pygame.key, and that tells us that. So now each one of these has an index for each key possible. But pygame has some built-in variables from which we called from here that can tell us which each key is, such as arrow key or space. So if we go here like if k, or wait, if k, this is if left, this is if we press the left arrow key. Wait, where'd my cursor go? Left arrow key. Now we press that, we want our player dot x dot wait dot self dot player dot rect dot x is minus equal to, let's go here with 5 for now. We're gonna eventually assign that to a variable. First, let's actually add our player into the render thing. So our player is gonna be on top of all our 4 tiles. So we want player dot render self dot player comma self dot screen. So this will render a player on top of everything else, because, oh wait, we're gonna render that each frame. So we have this right here. This will render each tile. Then it's gonna draw our player. So our player is always drawn on top. See, there's our player, but it's off for some reason. Okay, that ran into an error. We did something wrong. Self.player. Wait, was that error? Player has Oh, we're calling player from ourselves. I thought this was from the main thing. Okay, yeah, we did something. Oh, that should be minus equal to 1. Like have it move over 1 tile. Why are we even limiting our frame rate? We have a clock. So we have our clock, so at the end of our update, self.clock is or self.clock.tick. Let's keep this at 60 so we can actually have a solid frame rate for testing. Wait, so whenever we render player, we should have probably offset our Y by like half the tile size, or no, by tile size, because it looks like it's the wrong tile. Player minus tile size, this should offset it so it looks like it's in the right one. That looks like it's in that one, but we want to render in the one next to it. It's putting the center of it, not the one we want to see. Now this is working. Whenever we put left, we're going to the left. So now let's finish our movement script. Copy and paste this 4 times. Left. So now whenever you go right, this one's going to be up. This one's going to be down. So now to do this, we want right would be +1. Down would also be +1. And the last 2 are for the Y value, because up and down is for the Y axis. So now if we start this, oh, what did I do? Line 32. Oh, we didn't close it. I accidentally hit backspace somewhere, I think. Now we should have this finished. Now we can walk around our area. The only issue is our player is just a little bit too big. We might make a smaller one in the next video. That's all for today's tutorial. Thanks for watching.